So yeah, so I just posted like worksheet 6, right? It was this Saturday, I think I just posted. Let me see. Non-meeting. So yeah, you probably you didn't have much time to do worksheet 6, but maybe I can start a little and then yeah, I posted chapter 12 handout 1 and 2. We still have handout 3 for chapter 12, which I will post week 9. Okay, so that's test for independence. So this was worksheet 6. Okay.
This is chapter 12.
Worksheet 6 is actually based on chapter 11, right? Because it talks about the hypothesis test for a chi-square test statistics. And it has given like a lower tail test, right?
Yeah.
So yeah, part of it is from chapter 11. And yeah, you will have some, actually, let me look at the, so chapter 11 handout. Yeah, so we got introduced to chi-square test in chapter 11, right? When to reject. So they have these conditions. Pretty much, we also got introduced to the F statistic, right? Which is always an upper tail test. Probably you have reviewed chapter 11, I think. Okay. So yeah, let's just do maybe 1 or 2 problems today, and then if any students come, if they have any other questions, they can go ahead and yeah. So okay, let's read the first question. So here they have actually given us, they've already told us it's a lower tail test, right? Yeah. And the alpha significance is 0.05 and test statistic is 41.7. So they have given us the test statistic. They have given us the degree of freedom, which is 55. So what is the thing? First question they ask. Use the p-value approach. Decide whether or not to reject the null hypothesis. So for a chi-square test statistic for a lower tail test, so if we, I think I have given the Excel sheet too, right? Let's see, chapter 11. How to calculate the chi-square test statistic for a lower tail test, because in the question it says lower tail. So for p-value, we have to use Excel, right? So it would be chi-square dot dist, then you put the test statistics value, then the degree of freedom, and then you have to put the function true for a lower tail test.
Okay, this is for essay?
For a lower tail chi-square test, yes. Chapter 11. So we have to use Excel. Yeah, you're right. So let's open the Excel. So in the real exam, I will not tell you to use p-value approach, because for p-value approach, you have to use Excel. And during the exam, you guys don't have access to Excel. So most likely I will ask you guys use the critical value approach, which is the part B.
Okay.
Okay. So let me move this up. So the function is chi-square dot dist, because it's a lower tail, right? So lower tail is chi-square dot dist. Then you have to put the chi-square value. What is the chi-square value in our case? What is it? 41.7.
Oh, X test.
Okay, so 41.7. What's the degree of freedom?
55 이다. 55 again.
55, okay. And then true. It will give us the p-value. So we got the p-value in Excel. So if I write it down, let me do one thing. Let's see if I can move these things down. It went down, right? Okay. So for the p-value approach, so lower tail p-value, because in the question it is mentioned. And how do you calculate p-value? We have to use Excel in this case. So it's chi-square dot dist. Then you have to plug in the chi-square test statistic value, which is 41.7, degree of freedom 55, and it is true. So we got the value as 0.092965. 0.092965. Okay, so should we reject or should we not reject in this case? Because our p-value is greater, right? It's not less than. So
Yeah.
because we cannot reject. So do not reject, right?
Do not reject?
Yeah, because the p-value that we got is bigger than the level of significance. P-value has to be less than alpha, right? To reject.
Yeah.
But because it is not less than alpha, so we do not reject. So do not reject H naught. That means HA is unsupported. Okay, so this was very easy, straightforward. But let's now look at the case for the critical value approach. So for critical value approach, you guys know that the chi-square test statistic is always positive, right? And they have a lower tail and they have an upper tail. But for our case, it's lower tail because it's already stated in the question, right?
Mm-hmm.
So what's the critical value for chi-square? When the critical value, so lower tail critical value of the chi-square, alpha lower tail, right? So I can write 0.05 lower tail, and degree of freedom is given is 55, right? So you have to use the chi-square table. So let's open the chi-square table. Yeah, chi-square here. If you watch chapter 11, you know that the lower tail is in the upper row, right? Upper row is the lower tail, and
So this
bottom row is the upper tail for the chi-square table. So it is in the lower tail, right? So 55 is page 2 maybe. Yeah. So upper row is lower tail, and this row is the upper tail. So lower tail 0.05 is here. And what is the degree of freedom? 55. So this should
38, 38.9.
This should be the critical value, right?
Yeah.
So yeah, so we found the critical value. So see, don't forget that the upper row is always the lower tail value. Okay, sometimes you can mix it up if you're not careful. So this is 38 in that case, the critical value, 38.958. So let me actually use a red color, 38.958. Okay, and you know that this is the rejection area, right? But what is the not the example question? The example question problem is 41.7, which is here, right? So can we reject? No, because it doesn't fall in the rejection region, because 41.7 is greater than 38.958. to reject, it has to be lower than this, right? But because it is not, so we cannot reject. So we will get the same conclusion, cannot reject H naught. HA is unsupported. So to solve this problem, you can either use p-value approach, you can also use critical value approach. But the problem with p-value approach is you need Excel to solve it, right? But to solve the critical value approach, you don't need Excel. You just need the chi-square table.
Okay.
So yeah, chi-square table 0.05, degree of freedom 55, and I told you that the upper one is the lower tail, right? And then you find it. So in the exam, you guys should have the chi-square table to solve using critical value approach. Okay, critical value approach. Okay, so very straightforward. It was no students came. Okay, no worries. So similarly, you can do question number 2. But in question number 2, it's a two-tailed test, right? Two-tailed test at alpha equals to 0. So yeah, let's do question number 2. Let me move this down. Okay, let me see if I can move further down. Yeah. Something wrong. Why can't I take it down? Okay, anyway. So for a two-tailed test, why can't I make it down? Yeah, now I can scroll it down. Okay. So for a two-tailed test using a p-value approach, what do we have to do in this case? So p-value approach, chi-square test statistic is given 10.2 and degree of freedom is given 26, right? So for p-value approach, we have to find both upper tail and lower tail, right?
Yes. So
upper tail p-value, because it's a two-tailed p-value, right? P-value would be what is the chi-square dot this dot rt, right? So chi-square dot dist dot rt. Then you write the chi-square value, which is 10.2, and degree of freedom is 26, right? So you don't have to write true for calculating the upper tail test.
Okay.
So in that case, so let's write it down, chi-square dot dist dot rt, because it's upper tail. And what is our x? 10.2. And the degree of freedom was 26. So we got the p-value is 0.9976 to 4 decimal places, right? So 0.09976.
It's bigger than alpha.
So no, but we haven't finished yet. You also have to calculate the lower tail p-value.
Yeah. Okay.
Chi-square dot dist. Here you have to write true, right? Because it's different a little bit. So if we calculate the lower tail p-value, so chi-square dot dist dot rt, 10.2 is the test statistics, degree of freedom is 55, right? Oh no, 26 here, sorry, 26, and this is true. What?
Yeah, I have this problem too. I have this problem too. I make and then put a true and then it doesn't show anything.
Because it cannot be dot rt, it should be dot dist. Yeah, because it's a lower tail, right? You cannot write true in a RT. So point.
That's why.
Yes. So it's point. What is the value? 0023 87.
So I need to write down this. We don't need to put.
You don't need to put .rt for lower tail. Let me highlight it in red, right? So it's only .dist for the lower tail, the formula.
Oh, that's why. That's time what?
Yeah, that is the reason. So anyway, but so now which p-value we should consider, and because it's a two-tailed, we have to multiply the p-value times 2, right? So which p-value should you take? Should you take the upper tail p-value, or should you take the lower tail p-value? Why can't we take the upper tail p-value? Can you multiply this by 2? Can you multiply by 2? It will be bigger than 1. It will be 1.98, right?
So but this is reject. Because
probability cannot be greater than 1. So we cannot pick the upper tail p-value. So we cannot choose this. Because the p-value is greater than 1. But the lower tail p-value, we can multiply it by 2, right? 0.002387 times 2. This is 0.004774, right? So this makes sense. Another way you can find which one to pick, if you compare the chi-square test statistic value with degree of freedom. If your chi-square test statistic value is less than degree of freedom, it should always go to the lower tail test. So chi-square test statistic value less than degree of freedom. Is this condition true? Let's check. Is 10.2 less than 26? Yes, it is. Yes. So we should only choose the lower tail p-value. So lower tail p-value times 2 will give us this p-value. So now let's look at our p-value with the level of significance. So our p-value is 0.00. Let me use a different color. Our p-value is what? 0.0047. I don't like the purple. I like the light blue. Okay. 0.04774, right? And what is the example p-value? 0.01, right? So it is less than 0.01, right?
Yeah.
So we reject H0. So therefore, reject H0. And if you reject H0, we accept alpha, like alternative hypothesis. So yeah, these are very straightforward for the p-value approach. But for critical value approach would be the diagram way, right? You need to know how to read the diagram. That's the most important for chapter 11, reading the chi-square test statistic. So let's go to our chi-square table. What was the, and it is a two-tail, right? So two-tail, therefore alpha has to be divided by 2. So our original alpha was 0.01. If you divide it by 0.005. So now 0.005, we have to calculate both the upper tail and the lower tail. So 0.005.
Lower.
Let's see, 0.005. Lower tail first. Yes. And the degree of freedom was 26, right?
26.
So it's 11.16. So this value is 11.160 for the lower tail. What about the upper tail? Upper tail will be in the bottom row. So bottom row 0.005 is where? Here, right? And 26, the 26 is 48.290. So 48.290. But I also told you how to check which tail to select, because our chi-square test statistic is less than degree of freedom, right? So we only have to choose this area, shaded area. So let's look at our question test statistic. What was the question test statistics? 10.2, right? 10.2, yeah. So 10.2, if I use a different color, 10.2 falls in the rejection region, right? So because 10.2 is like less than or equal to 11.160, it falls in the rejection region. So we reject H0, right? So if you reject H0, that means you accept HA, right? Accept the alternative hypothesis. So it doesn't matter if you use p-value approach, if you use critical value approach, we will get the same answer, right? And in the exam, I will ask critical value approach because I cannot give you Excel in the exam, right? So you can use critical value approach to answer this question. Okay. Let's see. Question 3 is still chi-square. Let's actually do the question number 4 first, because we have only like around 7 minutes. I can do question 3 too. That's not a problem. So question 4 is a different question, not chi-square. It's F-test statistic. So F-test statistic is always an upper tail test, right? If you have read chapter 11, you know that. So let's look at that. And one more thing in the the test statistic is that they have 2 degrees of freedom, right? DF1 and DF2. So if you want to calculate the F-test statistics, you have to use, let's go to module. F-test statistics, p-value in Excel, chi-square. I didn't give the F1 yet. Let me see. Okay. Yeah, I gave here F-test statistics. So if you see what's the formula for the upper tail, because it is always upper tail, right? So f.dis.rt, then you put the F-test statistic value, then the degree of freedom 1 and degree of freedom 2. Okay. So for this, solving this, if I use the p-value approach, I can use p-value approach, or let me use this color. Okay. P-value approach. So yeah, I have given you guys the f.ist.rt, then the here f-test value, right? Degree of freedom 1, degree of freedom 2. This you have to do it in Excel. F.ist.rt. So f-test statistic is 3.41, right? Okay. What's the degree of freedom 1? 20. And degree of freedom 2 is 10. Yeah, so let's put it in the calculator. Delete f.dist.rt. So the 3.41 is the statistic value, and the first degree of freedom is 20. Second degree of freedom is 10. 0.025217, right? So we got the p-value as, let's take 4 digits, 0.02522. 0.02522. Okay. So this is the p-value. So is this p-value greater than alpha? No, because our p-value is less than alpha. So our value is smaller than 0.05. So we reject, right? Because p is less than alpha. This is true. So we reject H naught except HA. Okay, so this is very easy if we do it the p-value approach, but I cannot give you Excel. So let's take a look how to solve in critical value approach. Okay, OACH. So the chi-square 0.05, and it is always upper tail, right? So let's open the F table now. F table is here. So what is our numerator degree of freedom?
20.
First one is 20 or first one? Yeah, first one is 20. Yes. So numerator is always on the top corner, right? And the other one is 10. So this is 20. Let me magnify a little. And what about the other one? It's 10. And what is the level of significance? 0.05, right? I think in the question it was 0.05. 0.05. So let's see, let's cross these things out. You should do it with a pencil. Okay, so this should be the value, right? 2.77. So when we draw the F distribution curve, 2.77 is here because it's always upper tail, and this is the shaded region, right? And so what is our test statistic in the question? 3.41, right? So, yeah, 3.41. So in our, we found the critical value to be 2.77, right? So let's first write the critical value. If 0.05, we found 2.77. And our, in the question, it was given 3.41. Does it fall in the rejection region? Yes, because 3.41 is greater or equal to 2.77, right? So it's greater than 2.77. So that means, so reject H naught. And we accept HA. So this is easy too. You just need the F table. Once you go to the F table, it's very easy to solve this type of problem. So yeah, we did question 4. So yeah, let me finish question 3. And there is, I think, one more question, right? The question number 5. So let's do question 3. This. Yeah, maybe I will ask Ing how to solve it. Okay, so use the p-value approach. This already said it's an upper tail. Chi-square test statistic of 100, degree of freedom 75. So Ying, what would be the formula? P-value approach.
You want to approach? Use the essay?
The p-value approach, yeah, the first one.
Best tester and 100.
So it should be RT, right? Dot RT.
Yeah, RT, yeah. It's
then
up.
100.1 and 75. I don't have to write true because it's an upper tail test. So chi-square dot this dot RT 100.1 75. What is the p-value here? 0.02853. So because the p-value is less than alpha, right? Our p-value 0.02583 is less than or equals to alpha, which is 0.05. We reject H naught, right? That means accept HA. So how about the critical value approach? Good thing in the question, they already said that it's the upper tail, right?
Yeah, we use the table.
So not the lower tail, but the upper tail. So we use the table to find the upper tail critical value. So chi-square, upper tail, and we need this information. Degree of freedom 75.
25.
And alpha is 0.05. So 75 means it's not on page 1. It's here. 75. Upper tail is, let's use a different color, purple. Okay. Upper tail is in the bottom. So 0.05 is here, right? 75 is here. What is this value? 96.217. So we found the upper tail critical value, right? Upper tail critical value, chi-square 0.05 UT, or you can say chi-square 0.05. The upper tail value is 96.217. So that is the critical value, 96.217, and this is the rejection area. And in our question, what was the chi-square? 100.1. So 100.1, of course, falls here, right? 100.1, because 100, not 1, just 100.1. 100.1 is greater or equal to 96.217. So we reject H naught. That means accept HA. Okay. So pretty much that's it. So I think we have covered worksheet 6. Maybe we only have one question left on worksheet 6. Right? Question number 5. Let me open the worksheet 5. Import. Yeah, just we had one question left. So yeah, you can help me with this thing. Two-tailed test, F-test statistics of 2.17, degree of freedom 25 and 20. So if you have to find the p-value approach, I said that F distribution is always
F distribution.
Yeah. So 2 times F dot this dot RT. The test statistics 2.17, degree of freedom is 25, right? The first one.
So, Professor,
yes.
The two-tail test, we have to add RT, the last 2 letter.
Yes, because F test is always upper tail. I told you that F test is always upper tail, right? If you watch chapter 11 lecture video, I mentioned that F test is always RT, upper tail. And why did we multiply by 2? Because it's a two-tailed. So F dot this dot RT. So let's first find the F dot this dot RT, and what's the 2.17? First degree of freedom is 25. Second degree of freedom is 20. Oh, you have to put equal to sign. So 0.04052. So you have to multiply that by 2. So it's 2 times 0.040552, right? So if I multiply this by 2, or 2 times, I'll get directly 0.081105. So this p-value, is it less than alpha? No, it is not. So we cannot reject, right? So do not reject H naught because our p-value is greater than 0.05, right? So do not reject. So that means HA unsupported. Right? So now you can do it critical value approach as well, right? We have to go to the F table. F table is here. So first one is what, 25 and the other one is 20. So 25 and 20. So we have to go to page 2. So 25 is the first one. Numerator, this is the denominator, 20. And what was the level of significance? 0.05, I think, right? 0.05, yes. 0.05. But the thing is, we have to divide it by 2, right? Because it's two-tailed.
Two-tailed, yeah.
So it should be
I always
0.02.
forgot this one.
Yep. See, even if I'm not careful, I can make the mistake. So it shouldn't be this one. It should be this one. So 2.40, right? So the chi-square, the critical value is the critical value if alpha is, or f 0.025, this is alpha by 2, right? Is 2.40. So if you draw the diagram, and it is always upper tail, so 2.40. This is the shaded region. What is our chi-square value? 2.17. So 2.17 is somewhere here, not there, right? So we do not reject because 2.17 is less than equal to 240, right? We do not reject H naught. So HA is unsupported. So yeah, we finished all the problems. So make sure you practice. So let me stop the sharing. And yeah, so let me stop recording.